So the first chapter is permutation and recurrence relation. So this chapter is having two parts. First part is permutation and the second part is recurrence relation. So we will be starting with the first part today, that is permutation. So you must be knowing what is permutation already because you must have studied this topic in your 12th standard. So what is permutation? Permutation is nothing but arrangement of objects. Okay, for example, let me take one simple example. If you have three objects, say triangle, circle and square, okay, and you want to arrange these three objects, so how many arrangements are possible? You can have a triangle can have a first position, square can have second, circle can have third, or if you fix triangle at first position, then square and circle can interchange their position, or you can have a circle first, then triangle, then square, or if again I fixed the position of circle first and we can interchange triangle and square. Likewise, how many arrangements are possible? So what we are doing, we are arranging three objects on three positions, 1, 2 and 3. So we are assigning each object one number, or we are mapping the objects to 1, 2 and 3. So let us write the definition of permutation now. So what is a permutation? So a permutation on the set A, set A is a set with n objects, on a set A with n objects or n symbols, is a bijection. Bijection means it is a 1 1 and onto mapping. It is a bijection 1 1 and onto function or mapping. From A to A. That is permutation sigma A to A, which is a bijection, is called a permutation. It's called a permutation. Let me take one example. So if you have the set A with 4 objects, okay, let us say A is 1, 2, 3 and 4. And sigma is any permutation on A. So the sigma is mapping the elements of A to themselves. So you say sigma of 1 is 3, sigma of 2 say 1, sigma of 3 let us say 4, and sigma of 4 let us say 2. So what sigma is doing? Sigma is mapping the elements of A to themselves in a bijective manner. So this sigma can be written in array format as like this. 1 is mapping to 3 under sigma, 2 is mapping to 1, 3 is mapping to 4 and 4 is mapping to 2. So we will write few notes about permutation. There is one more possible permutation on A, say tau, where you map 1 to say 4, 2 to 2, 2 can be fixed, 2 is mapping to itself, 3 to 4 and 3 to 1 and 4 to 3. So how many such arrangement of 1, 2, 3, 4 are possible? Okay, so let us write few remarks or few notes about permutation. So first, the set of all permutations on the set A with n objects, that is A is equal to 1, 2, 3, 4 up to n, is denoted by the symbol Sn. S, capital S, suffix n. Any permutation sigma belonging to Sn can be written in array format as array notation as, so you can write sigma as 1, sigma of 1 means where 1 is mapping under sigma, 2 sigma of 2, likewise n sigma of n. An identity permutation in Sn is given by, let us call the identity permutation by I. So a permutation which fixes the elements, which maps the element to itself, that is 1 is mapping to 1, 2 is mapping to 2, 3 is mapping to 3, likewise n is mapping to n.